All right, we're here, we're doing it. Well, I'm recording these daily dev streams right now, and I can either record them and supercut it after so it doesn't have spaces, or I can just live stream it. And so I've kind of incentivized live streaming because there's no way to really supercut a live stream because I talk the entire time. It is kind of nice to have the supercut, but I'm going to be very selfish and just do the live stream. What we're doing, I was just about to write the issue, but basically we want to, I guess the mega issue is improve KiCad compatibility. And how we're going to do that is by, right now, adding export to KiCad PCB from the CLI. And then we also want to be able to import KiCad PCB files, modules. KiCad kind of confuses me. I think it has this thing called subschematics or something like that. I don't know if it actually has like a PCB submodule. So that's something I'm going to look for a little bit. I wish I had done this on stream, but I just wrote the initial KiCad parser, which is this giant format here. It's an S expression format. And I got a full TypeScript implementation, nothing else, from ChatGPT 01 preview. And I played with it a little bit. I probably sent 4 messages overall. And it built a parser, and I had it do Zod types and check the parser. So we have this really clean API for parsing these into JSON. So we can take a look at that JSON, which I don't think I've actually done, so that would be good, just to confirm. I looked at the code and verified, yeah, it looks pretty good. So we sort of have this JSON representation of KiCad objects. So now we're going to see what we can do to visualize this. It wouldn't be a bad idea to snapshot this or something like that, but I kind of hate snapshots when you have a really big file. I think they're annoying and nobody actually reads them. So instead, I'm going to do smoke tests, which is basically like, you know, making sure it's not broken. So we're expecting the version to be defined. Let's say that the layers are defined. Yeah, layers is greater than 0. Actually, we know how many layers there are, and that shouldn't change. So we could keep the layer count pretty precise if we wanted to. Although there is a lot of layers. But we can log that length. And then I positioned my camera really poorly here. Okay, there we go. Yo, what up, Anurag? Anurag? Why do your name seems really familiar? Are we oh, and coming from X. Very cool. This is the first time I have streams working across every platform. Anyway, hey, welcome. Just doing some development, just coding. Just some standard Monday night coding. Let's see what this length is. Also, I don't know why it's logging so much. It looks like it's 29, so we'll fix it there. That'll make sure nobody breaks it. And then we'll set up CI to run some tests on this and stuff like that. I'm getting this giant logged object right now. I don't know. Oh, it's right there. Yeah, I'm kind of blown away at 01 preview. Kind of did this first shot. So yeah, that saved me a lot of time. We wrote a KiCad mod parser, and I think it, even AI assisted, took many, many days. So the fact that I was able to one shot, I mean, yeah, I basically did it in an hour. And that's pretty clean. I mean, could not ask for a better API. We also have Zod types on it to guarantee that we're getting exactly what we expect. And I did the Zod types after. So I asked 01 preview to create Zod types after it wrote all the parser and everything. And then I validated that it did everything correctly with it. And I got it all. So pretty crazy. Probably one of the only times I've used a single chat stream to develop as well. So maybe that was helpful. Okay, so what did I do? Add test for parsing. Oh, I guess the entire parser is in here as well. Entire KiCad PCB parser. KiCad actually has 4 different file formats just for, I would say, projects level definitions. The exact file we're looking at is this one. So we have kind of like R1C1, and just an 0603 and an 0402 component and a single trace. And then there's some reference designators and stuff like that. So this small PCB file right here creates this 500 or so lines of S expression. So pretty verbose, but not too bad, I would say. Some stuff is so funny, like paper A4. Like, what the heck does that refer to? There's no paper here. I have no idea what that refers to. That seems like the most legacy of legacy things. This is the schematic view. So, so I just hit the, like, go to PCB view on that schematic and then moved around some resistors, and we got this. So, just parsing it to JSON isn't doing that much. I mean, maybe it's kind of helpful, but maybe not the best thing. So step 2 is to convert this JSON into circuit JSON. So circuit JSON is a tscircuit defined format. If we go to our docs, there's a big doc page on it. You go to the bottom. It's still called soup specificate. Maybe we should quickly revise this because it's called circuit JSON now. It's not called soup anymore. Soup is a little confusing. It's a little bit of a weird name. So let's go ahead and change that in the docs repo. I'm going to try to use GitHub's built-in IDE for this because this should be a pretty simple change. Ooh, that's very white. Okay, so we're going to look for soup specification. Okay. We'll change that to circuit JSON specification. Yo, Josh! How's it going? Famous last words. Exactly. What? Let's use GitHub's online IDE. This will be fast. I believe that. I'm not going to change the file name because I don't want to deal with redirects. And instead of tscircuit soup, let's say circuit JSON is the name of the build. Yeah, let's just change it to circuit JSON aka tscircuit soup. That name soup is going to linger for a long time. I don't know why I named things in such silly ways for so long. I think at first, I felt like I didn't have the right to call something circuit JSON. Like that would be too much of a... Soup is a great word to have in a name. It is very unique, right? Like, you know exactly... It's a nice thing because you know exactly what somebody's talking about. It's like a good variable name because it's so specific. Nobody else is using soup for anything else. But I called it that because I didn't want to take the name circuit JSON because that sounds like a very... like something that would have already existed. But then I kind of waited like for 4 months and I realized there was no JSON specification for this kind of stuff in sight. So I just did it. Sorry, I just realized how small everything was. I don't really remember how to use this message. Rename circuit JSON. Hopefully this works. I never used VS Code's built-in source control stuff. I think that just pushed to main. That's crazy how easy it is to push to main. I don't care because it's docs, but man, I don't know. Yeah, just pushes to main. One click push to main. No, there's like, I think there's workflow checks on this repo. Yeah, definite YOLO. All right, let's see. What do we got? Okay, that'll fix itself eventually. Anyway, so we want to convert to that format. Once we're able to convert to that format, we can use circuit to SVG to get SVGs of our circuit, and hopefully we can just recreate this. If we recreate this, we've won in one direction, the conversion from KiCad to circuit JSON. Then we need to do the reverse direction, and then we can build that export button. So lots of fun, lots of data moving around. Maybe we can use 01. I've used, I think 6 or 7 of my 30 per week usages of 01 preview. So I only do use it for the hardest things. I do believe it's the best out there. When it was writing this parser, it thought for 62 seconds for the initial problem. And I looked at all the steps and I was like, ooh, it's really thinking. So I definitely think this chain of thought thing or spending a lot more time on harder queries is a good idea. The shortest amount of time I've had it think for is I think 4 seconds. So I gave it something that was too easy of a problem. All right, so KiCad PCB, let's see. Now I just got to think. I think I'll make maybe a separate Maybe it should be in the same directory. Okay, let's say KiCad PCB to circuit JSON. So this would be a good place to use O1 Preview for too. So I think I'm going to go for it. The only thing is we need to make sure it understands the entire soup specification or circuit JSON specification. So to do that, I'm going to give it a markdown file inside of this repo called snippets or something. My camera's in the way. Snippet. I just got a different camera holder, so hopefully I don't have to put a camera literally in front of my monitor. Snippet intro soup reference. I think this is it. Yeah. So this is a generated file from Zod types that has markdown describing everything about circuit JSON. So this is theoretically perfect for AI. So we're going to copy out that entire file and we'll start constructing our query. Let's hide everything over there. Who knows what's over there? O1 preview. Okay, so please write a converter from KiCad. What did I call this format? Let's do this in a different order. So first I'm going to give it this KiCad PCB. By the way, the other reason I really like it, it's so dumb, but even though you can infer types from Zod in TypeScript, I don't like to do it. Oh, this is also, this should be a yes, no bool. Sorry. I don't like to use the inferred Zod types because even though they're clean here, they get messy later. So I like to define both TypeScript and Zod types, and then you can use a utility type to compare them if you really want to make sure that they're always equal. Or sometimes there's a way to just do one and compare them all. In this case, since we have this kind of root schema, we can do that. But I don't like to mix them up. And another reason why that's great is because it's a lot more minimal for AI. AI doesn't have to think about Zod. It's like one less thing for it to think about. It can focus on writing basically JavaScript. If you can get it to kind of just write JavaScript, it's going to be a little bit better. So please write a converter from KiCad PCB from KiCad PCB to a circuit JSON array. Ooh, it might get this confused because I think it's called the soup specification still. Okay, then we're going to paste that. And then we're going to paste in our soup reference. I don't know if the name soup is used in here. Looks like the name soup isn't really used in here, so we might actually be okay. But I should probably put like a markdown thing at the top just to say this is circuit JSON. So let's adjust that. Yeah, people don't think to use this entire prompt. You can put a lot of data into here, but people don't think to do it because the interface is so jank. Okay, so we're going to do a big header, circuit JSON specification. And then we'll paste in all that markdown. Hopefully that works. The backticks make no sense because there's a bunch of open close. And then, yeah, hopefully that works. And like, I don't like whatever it writes. I'm not going to love it because it's not using my patterns. Like it's just doing raw stuff. But like that's why I kind of adapt my style to whatever the AI tends to output, with some exceptions. Like it's easier to adapt to the AI than to adapt the AI to you in a lot of cases. And there's some repos where I violate that convention, but the further you get away from AI, the harder it gets to leverage it. But that means you do have to deal with some really annoying patterns. Like for example, with Claude, I don't think this is true of ChatGPT, but with Claude in particular, it loves to use for each. I never use for each because it doesn't work with async await. But unfortunately, Claude loves to use for each. And we have it banned in our biome, our default biome JSON in most repos. So you'll have to convert it to get code merged. It's just very unfortunate. And it uses an any type right here, right? So not super great. In fact, it didn't use any of the types, which is unfortunate. So maybe I should have given it type definitions. But let's see. Looks like it did a thing. It's actually pretty short. I'm kind of surprised. It's not too long, maybe 200 lines of code. All right, let's test it out. Dear God, what did this AI train its models on? Yeah. I think they might have, like with all these for eaches, what they might have done is trained on they might have like run like something like Biome or Prettier on it before they trained or something like that. But you can't convert most for loops to for each. So yeah, I don't know. It's really it's pretty weird actually. I do wonder if synthetic data has to do with it though. Like they had a huge synthetic data set with for eaches. Another really fun thing to do is to define all the types for a project, which is how I made a tower defense game very quickly with Claude, and I just defined all the types for it ahead of time. So that's another fun way to do it. Okay, it's not doing imports, which is normal. So we'll just start setting up our imports here. Yeah, okay. I'll have to import the types later. It is pretty unfortunate it didn't import the types. I'm responsible for the bad code that AI is trained on. You've flooded the world with so much bad code. You've encoded it into, humanity forever. We'll never escape the AI local minimum we're in. I mean that's genuinely true for a lot of languages, right? Like for Fortran, for example, whatever Fortran style has been popular, that's never going to change. There's no chance that there will ever be enough code to like update that standard. I think, I don't know. Maybe there's more people that do Fortran than I think. Okay, convert KiCad to circuit JSON. All right, we did a lot. Let's see if we can write this to an SVG. So I'm going to add circuit to SVG. Then we'll adapt this test. I don't even think I'll just snapshot this test. Why not? I love a big test. I don't like unit tests. I like a big test that tests a lot of stuff, as long as it's passing. If it's not passing, then that's the worst thing. But if it's passing, it's like, oh, so stable. Nobody's going to break that. Okay, KiCad PCB, is that it? Okay, let's just make sure this doesn't error before we convert it to an SVG and do snapshot testing. Nice. Oh man, I'm already. Doesn't that just give you like the shivers, right? When it wrote so much code. Oh, I can't wait for this to work. Oh man. All right. You should make an end-to-end test framework for the thing formerly known as soup. Call it hot pot. Oh my gosh, I love it. I love it. Oh my god, that's so good. Hot pot. Soup is a super underutilized kind of like verbiage from soup. It feels super underutilized in programming, like ingredients or whatever, just like that kind of framing of a problem. It's probably for the worst though. Super unclear. All right, so I have to get SVG snapshotting working. So luckily I have written a module for this, bun match SVG. So this is an SVG snapshot tool built into bun. So I'm going to copy those instructions. I am going to do use this feature of bun where it will run a file ahead of time. So test fixture preloading or something like that. So we'll set that up. Fixtures, preload. So this is just a file that runs before any other test. And then I have to tell my bunfig to run that file. So bunfig.toml. And all we're doing, bunmatch SVG just extends the global expect object. So you just have to import it in your preload, and then you don't have to do anything else, and we'll just have new methods available on our expect. So I don't really like that pattern, but I think it's normal for this kind of stuff. For bun to override this expect object. So anyway, now we have like expect to match SVG. And unfortunately, with Bun, they don't have a feature where you can get the test path. And I haven't complained loud enough to Jared yet, but he should really add that feature. It makes this so hacky that I have to pass in the test path. We also have to convert it from an SVG. So let's see if I can figure out the usage. Circuit JSON to PCB SVG. Sounds good to me. Circuit JSON to PCB SVG. Circuit JSON. Okay, that should do it. Go, go, go. All right, moment of truth. Let's see how this guy looks. I'm going to get a browser up. Oh, it's empty. Sad face. That would have been so cool if it worked. Now we have to debug AI generated code. A special hell. Drum roll, yeah. You can only get lucky so many times. Yeah, throw some Fs. Throw some Fs. Appreciate it. It did do any casting for this. I mean, it makes sense too because I gave it really poor type definition. Why is it complaining? Oh, import type. All right, let's start by logging out that circuit JSON. Let's see, PCB silkscreen racked. Oh, I see the problem. This is actually pretty easy to resolve. In the docs, Zod has two types associated with it. Zod has input types and inferred types or output types. And when it defined all these elements, it used the input types. But we actually want to use we have to pass into this next step is the output types. And because everything is anycast, I didn't realize this was happening. So a couple ways to fix this. The easiest, though, is just to use the Zod types to parse the JSON that's coming out, and that should probably fix it. So we'll add soup, and then just to test my theory, I guess what I'll do is this module hasn't been renamed yet. Any circuit element, okay, and then I also need Zod. If I don't have it, I think I do have it. I think we can do, yes, that. Okay, so that should convert it from input types to output types. This isn't the right way to do it. This should be done inside of this convert module, but I just want to make sure that parses. Yeah, we got a lot of failures. Okay, cool. Oh boy. Invalid enum value, expected top, bottom, blah, 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 received edge cuts. That makes sense. KiCad layers are not the same as circuit JSON layers. So that totally makes sense. Edge cuts actually isn't really a layer of a PCB. The thing with PCBs, they've been around a long time, since the 80s when these file formats were defined. And people like to override and mess with things. So edge cuts isn't a layer. It's where you're cutting the board out if you're kind of laser cutting the board into a particular shape. Like you can imagine a circle PCB or something like that. Unfortunate, but we'll need to do a mapping between KiCad layers and tscircuit layers. This is probably where I might need to do some unit testing. Let's see. Let's look at these input files. Convert footprint to PCB component. Takes a footprint. Yeah. I almost want bun style unit tests for each of these. Or I could just define these types and then fix all the type errors. I could put in all the types and ask AI to fix all the type errors. So that's another option. Let's try that. AI got us into this. It can get us out. So we'll import from soup. And then the easiest way to do it is just set the output type to always be any soup element or any circuit element. but that would kind of backfire because the type errors wouldn't be as good. So we should explicitly import each of these. You know what I'm going to do? It's a little bit of a hack. It's an anti-pattern, but I'll call these import type star as CJ. So normally we don't do this, but it's going to make my life a lot easier for auto completing right now. And I can just have AI fix it after. Okay, so PCB component. Yeah, because I don't remember how all the names work. All right, so we're starting to get type errors. For converting from millimeters, actually, if it's in millimeters, you can just do this. But we also have a millimeter module that'll convert things. Oh man, this is gonna be gnarly. Oh. I think I just wanna help the AI understand how this works. So I can do cj.rotation.parse, which should fix it. CJ cannot be used as, oh my gosh. All right. Can't import as a type because we're using values from it now. Okay, cool. That passed. Map layer. What's that function defined like? Oof, that's tough. Yeah, it's almost like if we don't support the layer, we kind of don't want to put this in. Oh boy, this is going to be... Hi. All right. We're going to throw for now. String is not assignable to blah, blah, blah. So instead of returning string, we'll return layer ref. I'm just going to comment that out for now. Oh, these don't exist either. This tscircuit just works a little different. All right. I should have done this differently. I almost want to like re-prompt the AI, but actually give it type definitions. The thing is, the type definitions for soup are really long. It's like really, really huge, and it's mixed in with Zod. I really want the output definitions to be their own TypeScript types, so Zod doesn't get confused. But the other thing we could do is we could do CJ dot, I don't even know if this type exists, silkscreen racked dot parse. Okay, that's another way to do it. That's pretty clean. So now we can use the input type. That's pretty clean. And that actually should fix our output type here. Okay, cool. Actually, that's awesome. Let's do that. All right. That layer thing is going to be a huge problem still, but... Oh. If... All right, that's super hacky. Oh, this can be defined like this. Okay, there we go. That's better. That's better typing. Okay, cool. All right, what else can we mess with here? PCB traces. Okay, PCB traces. Let's get a type on this. CJ.PCB trace. CJ is circuit JSON, if that wasn't apparent. Okay, and then we'll do cj.pcbtrace.parse. So what happens when you mess up the prompt? I should have spent 10 times as long on that prompt. Foolish. All right. More parsing. Prompt twice, debug once. Yeah. Debug a tiny bit and then give up and reprompt. I think that's probably the way to go. It's complaining about this, which is fine. We'll also throw in the prompting here, or the parsing here. All right, that's approximately right. We can try returning cj.any circuit element. Make sure that we hit everything. If it returns anything unusual now, it should catch it in our ties. We're not getting any errors. Let's try again. It's going to throw because those invalid layers probably. No, we're getting invalid input. Received undefined for path height. Oh boy, this is a real mess. I don't know. This is a kerfuffle. Any or null that can be turned into. Oh yeah, look at that. CJ dot PCB pad. What is that? SMT pad. I don't know. I feel a little. I don't know. I think we might be in too deep here. There's problems. there's issues. Oh. This is the other thing. I mean, maybe I'm using Zod a little bit wrong. I don't know. But sometimes it says undefined path height, and I don't have the full path because I'm not parsing like from a root object. Maybe it would have been better for me to parse from a root object, but then that makes the errors harder because there's some ambiguity that Zod might not be able to resolve. So, like right now, I have no idea where this happened in Zodland. That's a great song, In Too Deep. Oh, a classic. A classic. That's some alternative rock hits. In Too Deep? I'm in too deep and I'm trying to keep. Yeah, it's a classic. Absolutely. I am very much in too deep and I do not feel uplifted as a result. Received undefined path. You know what? When in doubt, let's throw some log lines in. Can I get footprint? I don't know. I don't think I have type definitions good enough to fix it. So I think I have to do this manual mode. I think we just got to go in. We got to commit. What are these things? KiCad footprints. Now I actually have to figure out what these things represent. Footprint. It looks like a footprint is composed of a model, which is... Oh, that's probably a 3... Oh, that's a 3D model. Okay. I looked at 0 KiCad code for any of this. I just looked at an output file. This is basically reverse engineered with the help of AI, which I guess the AI probably has read some stuff. Okay, so footprint... This is probably footprint lines, footprint text. So that's like its silk screen. But what about, and pads. Okay. So a footprint is composed of these things. So you've got your footprints. You've got your setup. What is setup? Okay. That doesn't look too interesting. So you've got your footprints. You've got your nets. You've got your layers. grrect. What is a grrect? Graphical rectangle element. Okay. We don't have an equivalent of that in circuit.json right now. Segment. What is a segment? Start, end, width, layer. Okay. So those are tracks. Let's take this from the top. Let's just worry about those tracks. I took 5 seconds to actually understand what we're doing, and I feel a lot more confident now. None of this is that complicated. Okay, group segments by net. Why the hell do we do that? Net ID. Yo, what up? Selen, how's it going? feel like I said your name wrong, but my apologies. It's good to see you. We work near each other in Solaris. Let's see. PCB traces. Convert segments to PCB traces. This is truly like the messy middle where I have no idea what's going on. Okay, segments. We're making a route. So we're constructing a route here. I feel good about this. Let's run it. Okay, error. Route 2-layer message required. Okay. Let's try using a little bit of TypeScript foo here. Is there like a... Miss you too, man. I know. Never around. Never around. I'm, you know, just here in my house mostly. Yeah, you know, co-working spaces are great. And I get some really good work done. But I'm also like, whenever I have a call, I'm like, I'm not going to go in today. I interviewed for the AI grant today, actually. So we'll see how that goes. Feels a little bit like, you know, maybe, you know, I think we're the foundation of React for circuits in the future. But, you know, I get it. I get it if people don't see that. Like, it's a leap to see that, I think. But I do think it's true that a bunch of people are going to generate circuits with tscircuit in the future, which looks nothing like this. We're in KiCad land right now. We're trying to parse other people's formats. So that's why it's like, looks like it was written in the 80s. Blame everything on 80s programs. All right. We're not using any of these. This is the only one we're doing. Convert segments to PCB traces. And we have some errors here. Let's try fixing with AI. Let's see what it says. What did it do? Oh, route type wire. It was just route type wire issue. Sometimes TypeScript should give a little bit. I don't know. I guess if an AI could figure it out, maybe I should have been able to figure it out. Who knows? Okay. Let's see. Oh, there we go. Now we're parsing. So if we parsed it, does that mean we should have gotten an SVG? So we should have something fun to look at. And we don't. Let's log it. Maybe it didn't make any traces because it's deeply flawed. It did make a trace. Interesting. Let's go a little deeper because I'm not seeing too much on that object. Okay, so here's what it's supposed to look like. We should have a single wire going from here to there. That would mean we did this correctly. But a single point does not make a wire. So let's see. I think I need to look at our example data for a second. KiCad, PCB. What do we have here? Segments, I think it was called. All right, so we got a segment start, end. And it looks like we 155, 105, and then 154.54. Okay, so I'm not seeing the end of the segment. Convert segments for segment of segments. Oh, this isn't how these work. Huh. Okay. We need to add. Yeah, AI did not read that specification well. I think it's because the specification was like in JSON. It was too jank for the AI. So converting that repo to have like normal TypeScript types is probably the way to go. Okay, let's see if that does it. Okay, now we have an error. Snapshot doesn't match. That's very good. So we'll make it so it updates our snapshots. Open this guy. Whoops. Open this guy up again. Nice. That's what I'm talking about. That's how we do it. All right. Let's get some other elements. Footprints. I don't totally understand how this works. I wonder if I'm going to try to get Claude to like graph this for me. I think you probably posted an emoji, Josh, but Restream doesn't show it to me, which is very unfortunate. Help me visualize the elements of this. Oh, it's a clap emoji. Thank you. Yeah, Restream's chat element is kind of bad, but it lets me see Twitter, which I like. Help me visualize the elements of this in a graph. I think it can do this with Mermaid. The data structure of this in a graph. And I can be extra lazy because this is Claude and I have like unlimited. You know what's funny is the clap emoji did eventually load. So I do see the clap emoji now. Whoa, what just happened? Whoa, what's going on? No! There we go. Okay, cool. All right, let's see. KiCad PCB version blah, 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 blah. Okay, this is basically, yeah, you know what? Actually, I'll take it. So you've got a footprint, you've got a GR rect. What I want to know is where is the footprint used? Like, are we redefining the footprint? It was a slow clap. I love it. I don't get it. So what I was thinking is the footprint is like a symbol, and then you place multiple versions of the symbol, but it doesn't seem like that. It seems like maybe if there's two footprints that are the exact same, they're both just put down. Let's take a look at the data. So footprints. Man, S expressions. Footprint. Yeah, see, this to me looks like a symbol definition because this does not have a reference designator on it, meaning like C1, C2, C3, like one that would refer to a specific, it looks not an instance, but like a class, basically. So I don't think this is... Oh, wait a second. Property reference. Oh, never mind. I'm wrong. There it is. Reference C1. And then it even has at. Sounds good to me. Let's do it. All right, footprints. We can skip the PCB component. We don't have to do that. Nobody can make us do that. Let's see if that works. Unknown layer, F, paste. Paste is where your paste goes. You put on solder paste, and it gets melted to melt the chip to the board. So the paste layer is not represented specifically in tscircuit right now. It's actually kind of a problem, but let's just build it in so it ignores it. This is a little, oh man, there's not like, I think I need to make these return like nulls. You know, it'd be really fun is if I used, I don't think there's enough data for AI to use it, but if I use that new TS effect library. Everybody is using this TS effect thing because it lets you design this really, really safe flow control. But I think AI would get confused. I don't think there's enough data. I want some normie code. All I want is normie code. Okay. So we're going to have this guy return null if there's an invalid layer. Oh, pad that layer. So it can exist on multiple layers. Oh. feel like this whole thing is done wrong. All right. This could return. Let's have this return an array. This is confusing. How can a pad can't be on multiple layers? It's not possible. It's a pad. A hole can be on multiple layers because it can go through multiple layers. Property description. Where are the pads? Oh, sorry. Okay, pad 1, SMD round racked layers. They do have it exist on multiple layers. That's really 3 pads. It's just a difference in the domain, how we've defined it. So we're gonna say ... PCB pads instead. We'll have this do arrays. I don't know how I feel about that. Maybe I should make it. Maybe I'm the one who should change. If the AI and the other person's file format is telling me I'm wrong, maybe I'm wrong. Just kidding. In today's landscape, you can never admit you're wrong. Just gotta commit. All right, then we're just gonna go through each pad, and at the end we'll return pads, which will often be an empty array. Whoops. I used to like do a lot of custom hotkeys in my VS Code, but I stopped because it's just too annoying, you know? Even though you only change computers every like 2 years or whatever, like, it's just like, I just go with the defaults. Become boring. Assuming first layer is the primary layer. Let's also call this the KiCad layer. We'll say layer equals... Maybe, maybe we do this or null. I feel like that's fine. See, like if you use tseffect, I guess you can return more advanced flow control. I haven't used it though. I haven't used it because my entire experience using tseffect or using any library that like changes your flow control is everybody is a little bit frustrated, and like just on principle, I try not to pick any technology where people are going to be frustrated for too long. They should be delighted before being frustrated rather than being frustrated and then delighted. I don't know if that's actually true. Yeah, like it's a little different, right? Effect, success, error requirements. You can define the different types, and then you get these nice strings. They need to have a good example somewhere though. I don't know. It's a commitment. If not layer, we'll continue, and otherwise we'll use that layer whenever we define the layer. Yeah, thank you, cursor. Oh, wait, so a pad can also be a through hole? Man, this is whack. Let me tell you, this is whack how this is done. So if pad.type is equal to SMD, yeah, this is whack. I don't know. I don't believe in it. I don't believe in how they define this file format. If I could go back in time, a lot of people have different things they would do if they went back in time. I would force everyone doing electronic software to use JSON. Okay, yes, that is unintentional. And then we're not going to return. We're going to do pads.push. And since this is a plated hole, we have to change the return type, because I didn't realize they consider everything a pad in KiCad. So this can be a PCB SMT pad or PCB plated hole. We're not going to return here. We're just going to push it. This is why you need type, like, man, I know very few people are like pro JavaScript over TypeScript in 2024, but like I can't keep track of things. You know what I mean? Like, I can't keep track of things, and like if I don't have types, like when I lose my train of thought, there's nowhere to come back to. You know, you're like, I would have to have a notepad and like write down everything I'm doing. But with TypeScript, you're just like, oh, next error. Okay, expected number received string. I would love to know what it's trying to parse. That's my biggest issue with Zod. Tell me what you're trying to parse when you got this error. Let me see. I think there might be. Can I think there's a way to maybe modify the error or catch it. Let's see, params. I wonder what's. I think safe parse might give you an opportunity to look at it. Yeah, safe parse. We could do this, or we could do a try catch. All right, so now we can say if PCB played a whole success, we're going to push it. Actually, you know, let's just do a warn for now. We're not going to log the error quite yet because I need a clean. Okay, so it's not here. It's up here. I think it doesn't like our width and height. Oh, because we're still doing millimeter strings. That was the biggest mistake of this AI generation, is I told it to use millimeter strings everywhere. Huge mistake. Even though they should go away in this parsing, so maybe that's not an issue. I don't know why this is messed up. We'll still do our safe parse stuff. Oh, this is kind of jank how I did this. .data or whatever. Okay, so we're successful, but we failed to parse every single SMT pad. So we're definitely doing something wrong with these SMT pads. I want to see the input. Zod is great when you can put a little bit of infrastructure around it, but I didn't put any infrastructure around this one. Okay, XY. This looks fine. Width, height, everything looks fine. What's it complaining about? All right, we'll log the error now. Invalid literal value expected racked. Path shape. Pad shape. Okay, so KiCad pad shapes are different. Let's see what we passed in. Oh, round racked. This is another thing with KiCad, is they love it when their rects are rounded. I forgot about this. Yeah, these guys. Yeah, they love when those things are rounded. I think we already wrote a parser for this kind of stuff, so I don't want to. Okay, we should support round racked, but we don't right now. So pad shape equal to round racked, or pad shape. We're just gonna hack it together. Maybe for this one we can use the UUID to make these a little bit traceable, but I don't want to. I think we're going to fail on a lot of stuff right now, so I don't want to get too. We're still failing to parse everything, though. Oh. I forgot a little else statement. Okay. Cool. I think we can remove there's a log line hanging out, annoying me. PCB SMT pad. I don't know. Where's that log line? Oh, it's up here. Okay. All right, cool. Maybe our snapshot is updated and better now. Ooh, it's worse. I think I know why, though. Or I have a hunch. Is there a little red dot? Yeah. Okay. I couldn't see it. There's a little red dot in the bottom left corner. I think all the positions are wrong. So you've got little dot in the bottom left and then the line in the top right. So somewhere there's some relative position stuff going on. So I remember that the segment is in the top right. I really need to get, if there was an AI that could analyze visual stuff, it'd be amazing. Yeah, this all looks like it's relative to something because it's all about 0. So maybe there is something like a position as part of the footprint. But I do not see anything like that. Oh, there we go. So footprint.at, and we need to do a translation up to that point. I don't think it has rotations. That's perfect. Okay. So we can be very lazy if we want to be. Although I think this is in millimeters for some reason. I could have swore. Let me see. Pad. No, it's not in millimeters. All right. So we should be able to just add it. I thought when I logged this, it was in millimeters, so I'm a little skeptical, but... Oh, it's because of this. This is actually pretty easy. So, position... yeah. Footprint.at.x. Wow, the initial parser did so good. Okay. Yay. A little bit closer. Starting to look similar. Oof. Wow. Let's see. That was a while to get this to work. Yeah, we're about 1 hour in. But not bad. Not bad. I'll take it. Take a second to hydrate, and then we'll probably want to do the silkscreen text, and then I might want to try to do, let's see, then we can do reverse direction and try to import to KiCad. And then once we have the two-way set up, it's kind of easy to create a bunch of issues and maybe set it up for Hacktober. Hacktober, when all the kiddos come out, do some open source stuff. All right, I've got my vitamins. Let's do our tests are passing, right? Let's do a checkpoint, and then we'll get a nice visual diff if we do PRs. I think this is the last one we won't do a PR for, or we'll push to main. After this, we'll do PRs. And that way we can see any differences in our snapshot testing. Okay, what did we do? Let's try using an AI commit. Let's see how well it does. I have it aliased. I use this thing called AI commits. Let's see, add KiCad PCB and conversion to circuit.json. Yeah, perfect, great. And we'll push that. Yeah, npm install -g AI commits to get AI commits. You will need an OpenAI API key, but I think they use a really dumb model because the commit messages sometimes suck. so probably not expensive. I doubt this does vias, so we'll want to try that at some point. the little holes through the board. Also, I should do a plated hole test. I'm not doing plated holes right now. So we can definitely test that out, but I'll probably do a separate KiCad file for that. And I can create issues for most of that too. Okay. The other nice thing about having really messy code, and this is bad, but I don't feel super attached to this code because I've only spent a total of 2 hours on this whole repo. So how bad can I feel if somebody like introduces something a little bit jank? Like a little bad, yeah, but not as bad. It wasn't like I spent my life perfecting it. Yeah, so we're going to do opposite direction now. So we're going to do circuit JSON to KiCad PCB. For this, I'm going to use core so that we can write normal TS circuit code. Also use TSX for the file. No, I don't need TSX. I only need that for the test. KiCad PCB, we'll call this circuit JSON to KiCad PCB 1.test.ts. I like to just number test. I've gotten like annoyed when you're doing this kind of like integration style testing. It's really hard to name each test well, but if you're just testing a function with a bunch of different test files or whatever, just 1, 2, 3, 4, 5. Honestly, it's way easier to refer to them because yeah, if you're just running a bunch of test sets or whatever, sometimes you can do 1, 2, 3, 4, and then if you do have extra information, just add a dash and some metadata like bug with plated hole or something like that. So 1 dash bug with plated hole, so that can make life easier. All right, test expect bun test circuit JSON to KiCad PCB. Let's generate some circuit JSON. So I'm going to import the circuit element, tscircuit/core. I'm going to do circuit equals new circuit, circuit.add, board width equals, I don't know, 10 millimeters, height 10 millimeters. We're not going to insert a pad. We're going to be a little bit more clever. We're going to make a chip. I'm going to call it U1. Actually, let's just do the same thing as we did before. So resistor value 1K, or actually resistance 1K is what we say. Did I make this a TS file? We need to make this a TSX file. That's why my type hinting isn't working. Okay. Cannot find name React. All right, let's go to our TS config. This usually is an issue with, nope. Cannot find module React. Why am I getting this? TS, TSX. Oh, weird. This file is added explicitly here. That's strange. Let's fix that. Cannot find declaration file for module React/JSX runtime. Maybe I need React. Yeah, that's weird. I guess I need React. That probably makes sense. Cannot find declaration file for React JSX. Oh, do you have to install types for React? All these people complaining about the you have to restart the TS server. It's like a thing on Twitter. I think they're just not very patient, and I'm not either. Like, I restart it, but I think it does actually correct itself most of the time. Just people are impatient and they restart it before it has time to correct itself. I think that's right. And then we'll do a capacitor. I'm just setting up something very similar to our thing right here. The capacitance and resistance doesn't matter. You can set to 0 or whatever, but I like to do it just because I like to set it to realistic values, just so that it doesn't look like nonsense to somebody who, I don't know. is inspired by it to create a circuit, and then they copy it, and then it's like some impossible value. Like you can't get a 0 microfarad capacitor, I don't think. I don't know what that would be. Maybe you can. It's some theoretical object probably. Cool. So we made our circuit. We can render it. We don't have to, but we can render it. That just basically compiles it. This is where we would normally run the function that converts it to KiCad. I wonder if we want to log it before we do this, though. If we want to just do a quick snapshot test. Make sure that we understand what we're looking at. Okay. Ooh, it failed. This is something I did recently. Some transient dependencies that aren't captured properly. I should just fix that. Okay, let's open this up and see what happens. It should look kind of similar. All right, it looks a little different, but whatever. Looks slightly different because I connected the wrong pins or whatever. But you know what? I like it more. It's got more personality, so we're going to keep it that way. There's no reference designators on this, which really bothers me. That's a big footprinter issue. We need reference designators on everything. Like R1C1 is a good example of what that issue is. This is the issue with missing see, R1C1. They don't exist. Where are they? Nobody knows. It's footprinter's fault. Okay, so we don't actually care about the snapshot, so I'm going to delete it. What we care about is that we're able to open it in KiCad. So convert circuit JSON to KiCad PCB. And circuit.get circuit JSON. PCB JSON. And then we want to have KiCad PCB. I don't know, S expression? S. What do you call that? S expression string? And we're just going to write it out to a file for now. Call it test artifact KiCad PCB. Okay, whatever. Okay, lots to implement here. We've basically got the setup. So I'm going to do a quick... actually, let's reset. Let's go to a new branch. We'll call it circuit JSON to KiCad. The goal for this, by the way, is like, whoops, stack plots. We basically want to have a file export to KiCad PCB. And the reason I want that is as we get more complicated PCBs, this keyboard PCB especially, I kind of want to export it out to KiCad so that I can inspect it for errors. So if we have a little export option here, I can load it into KiCad, do a quick inspection, and actually run KiCad's DRCs, design rule checks, because they have a lot more than us to make sure it's actually manufacturable, and it'll just make my life easier. So that is the main reason I'm looking into this. I know it's like yet another thing. We're building like so many things, but yeah. Okay. PCB test. Really all we did was write the test now. Okay, I'm going to create a draft PR for this. And then I'm going to ask Aider to implement this. So we're going to do aid. It's the first time we're running it. We're going to add the entire library. We're going to add... We have to be a little careful about the tests because we don't want to add in... We do want to add in that file. And we want to add in... test KiCad PCB slash parse. So the parsing test. Then we want to add in the test we just wrote. And we're going to ask the AI to implement everything. Okay, so please implement both. Maybe I should create... I really don't want it to add it to an existing file, so maybe we do... I'm going to just messed it up. Shoot. Okay. Aider is a little bit weird. If you rename a file, you know, you got to... It uses Git. So convert KiCad PCB to S expression string. All right. So now we've got these kind of boilerplate files for it. Okay. Unfortunate. Maybe instead of like doing this crazy thing with adding, what I'm going to do is explicitly kind of use aider ignore to do all this stuff for me a little bit. So I'll add an aider ignore file. Then I'll say ignore any SVG file. And I also want you to ignore any PNG file. I don't know if it picks up PNG files, but I don't want you to use those either. And then in our assets directory, I don't want it to look at the KiCad PRL, the KiCad Pro, or the KiCad schematic. Okay, so that'll make it easier for us to add. So now we can do aid / add tests / add. Did it add everything? Yeah, I got everything. / add lib, and I can say it should know what we want because we were pretty clear in the test how it should work. So hopefully it figures that out. So implement convert circuit JSON to KiCad PCB and convert KiCad S expression string, or convert KiCad PCB to, man, can you imagine before autocomplete typing these things in? I think there were people who were like anti autocomplete too. Ooh, maybe I should have committed something. I think I might have gotten confused. I think it got confused because I didn't get fully committed. You know what? I'm gonna stop it. I think I can go back to this prompt relatively easily, but let's do a quick commit. That'll also make it easier to revert. More bootstrapping. Okay, add lib, tests, and then let's try again. All right. Oof. And big initialization object. Do not want to write that by hand. $0.10. Test passed. Okay, I'm just gonna close some things out. Try to understand what it did for a minute. So it implemented this file. I don't know about this rotation thing. Oh, wow. Wrote this from scratch, basically. The S expression serialization. You know, it sounds like, oh, bad, but I think you actually kind of have to do it a little bit like this. Although there's a lack of escaping here, which is really bad. I think there's a better way to do this, probably. But I do think that S expressions are like way messier than you would think. What goes, like, it kind of mixes things. Like, for example, this UUID, see how it doesn't have quotes? It's like UUID is some type, some kind of implicit type here. So it's like kind of complicated. So it might be okay. This kind of looks terrible to maintain, but at the same time, it also kind of looks easy to maintain. So I don't know how that's going to be, but it said our test passed, but that seems unlikely to me. Oh, it modified our parsing test. It just modified the existing test here. Convert circuit JSON. So it converted back the file it created. I guess that's fine. But let's fix this one. I don't mind that it did that, but it's not really the point of that test. Okay, so this one should create a test artifact for us that we can open in KiCad. By the way, you should always remove these lines. Our linter should actually should error if you do these, but yeah, it's a little annoying. We should do some smoke test checks on this guy. I'm going to, I don't know. Yeah, we should do some smoke tests on that. We'll do that in a minute. For now, we have this new artifact file, so let's play with this. I'm going to add it to the gitignore just so I don't accidentally capture it. And you can kind of spam gitignore with stuff as long as like they're named well. Like test artifacts, that's a great name. We'll never need that. But you can kind of just put stuff in here if you're kind of playing with files locally. But if it doesn't start with test or artifact or something that's very obvious, like don't put like index, like something like that, because somebody will be like, why isn't this adding? And they'll be confused. Let's try opening this inside of KiCad. I'm really bad at KiCad though. I'm going to close out. I want to get to the welcome menu. There we go. Can I just drag and drop? Will it let me do that? No. If I hit this, it opens my last project file. I don't see an open. I do see import. Let's close. New project. Open project. We don't have a project. We just have a PCB file. Do we need a project file? We could try to generate a project file. I thought you could open these independently though. What was a pen board? A board file. I think a board file is a KiCad PCB file. So maybe what I can do is create a new project. So let's close. New project. Okay. Append board. We should just generate the full project file though, because this is a hassle. And then I'll just navigate to it. Shouldn't be too hard to find. There we go. There's our test artifact. Error loading board expecting symbol. I love a good error. Expecting symbol line 4, offset 22. Okay. This would be a good one for 01 to debug if I could fit everything inside of its okay, we're gonna just open both of these files and compare. Okay. Version, generator, general. The generator version is supposed to be in quotes, I think. Oh boy, these are not the errors I want to see. These are not the errors 01 would give me. That's not the right. Where was the file? Okay. Is it this one? S expression string generator version needs to be in quotes. And then generator also needs to be in quotes. Does version need to be in quotes? What's going on here? No, version is not in quotes. It's kind of like an int. Thickness isn't. And whenever you have yes, no, that's a Boolean, so it's not in quotes. Okay. Okay, we regenerated. Looking good. Let's do it again. Error loading board expecting symbol line 48. Making progress. Output directory. What the hell is that? I'm also noticing we don't have layers. Output directory. It should be an empty string. Is that inside of... Yeah, it's inside of PCB plot parameters. This indentation is very difficult to keep track of. I don't know. This is crazy. This is an insane approach to this, but whatever. I don't want to think about it too much. The tests are where the value is, because somebody can rewrite it, and as long as the tests pass, we're good. So we're building to get tests. Okay, did I rerun? Okay, line 25. It's weird how we are now back up here saying SVG precision. This cannot be quoted. Is that right? Oh, S expressions. Can I do this? This should also not be like, I don't know. I think the way this is being done, where I think this code is probably repeated, that just like basically stringifies this value, it's not great. All right, we regenerated. Let's try appending again. So that's why the error moved up, is because we put everything in quotes. Some of the pasted items were on layers which are not present in the current board. These items cannot be placed. And then when I zoom in, I can see the trace. So good news. A couple crazy things. First of all, this trace is upside down, which is really interesting. This trace is upside down, right? And that's probably because we use, this changes all the time. It is so hard to keep track of which system has Y coordinate up and which system has Y coordinate down. But evidently KiCad has y going up is negative, which is the same as a website. And we can verify that. It's really hard to see, but in the bottom, there's an XY position shown in very, very tiny, tiny text. And I can see as I move it up, it goes from 3,600 here to 3,400 here. So it does indeed go down as we go up, which means we need to invert all the X and Y coordinates, which means we need to start doing matrix operations, because you really, once you start inverting axes, you really want to build it, start using transformation matrix to make your life easier. You don't want to just be multiplying and adding things all over the place. That's a sure way to end up in a place you don't want to be in, where you've gotten very confused because you don't know what's being multiplied and added at what times or whatever. So, okay. The other thing is we don't have the pads. I'm okay with it being upside down for now, but I do want those pads. I demand the pads. So let's see if we can get pads. Just fix some of the code the AI wrote. We have a lot of type errors in this repo, actually. So another thing we might want to do is at least put TS ignores around our type errors, or TS expect error, because otherwise people committing to the code might create more type errors and not tell me. Sad face. I like where this is going. All right. Getting pads. Let's take a look at the file and see if any pads are coming in. So it's pad like that, I think. Pad. Footprint. Okay, there's our footprint. There's no pads inside of it. There's supposed to be pads. Are we even trying to make pads? I guess that's the first question. There's two things that might be failing to make our pads, because we're debugging kind of two functions at once. One of them is this S expression thing. Footprint tags. If we have footprint pads for each, we're going to convert a pad to S expression. So I think if the footprint has pads defined, it'll try to do it. So that means the issue is in our convert circuit JSON to KiCad JSON. What is this complaining about? Object literal. It's kind of dumb, but I'm just going to put TS expect error there. I don't know why that's happening. And we need to start prepping this code to be contributable. Get or create net ID. I don't know. That's interesting. Interesting. So it's using a global variable here, which is a pattern we... Oh, no, it's not. It's not. You pass in the net map. Okay. Very interesting. It has 3 parameters, so that's a pattern we don't like. We like to go named parameters. Is this a pre-recorded video? Spartan Don? No, it is not. We live stream daily, or I'm trying to do daily dev streams. You can go to blog.tscircuit.com, and then if you click dev streams at the top, you can see all of our streams, because I upload them after, and sometimes I supercut them so that they go a little faster. But yeah, no, this is live today. Whether or not I do it live is basically how I'm feeling. Width does not exist. This is, I'm also going to do TS expect error here. We're just going to be very, very lazy about this. It's pretty cool. I can see chat from YouTube now, because in the past, they probably would have just been like, it's probably pre-recorded. Yeah, I think he asked that like 10 minutes ago, so he probably dipped before that happened. I feel like if you think it's pre-recorded, you can look at the time though, because the time is at the top. Like, and the chances that the minutes would match exactly is low. And the chance I would edit the video so that it matches exactly is low. You can't tell what time zone it is. So, I mean, maybe that's an issue, but I think I have the time at the top of the screen. It's pretty small text though. Okay. Goal. get those pads loaded. Problem. We don't know why the pads aren't appearing in our JSON object. So where are they supposed to be added? We're debugging AI written code right now, so. Footprint.push convert PCB. Oh, well, that's why. The AI wrote, you may need to add logic. Disk. I'm just going to add all elements as a parameter to this. It's a little hacky. I'm going to add all elements as a parameter. And then we'll pass all the elements in if we can. And then we can try to find the pads inside. Okay, we got our footprint. At the end of this, we're going to return the footprint. We will look for PCB SMT pads. I like, a lot of people get confused because there's so much stuff going on. Just get laser focused. You want to make a square, you know? Right now I've been laser focused on squares and traces. Like just super focused in on that. So as long as you do that, like you're good. And because right now, if I just want to make squares, I only need to know about like 4 different objects. Elm.type equals PCB SMT pad, and we're good to go. Then we're going to do footprint.pads.push. Oh, is this a function? Does that function exist? No, it doesn't exist. They want me to declare it. I guess I will declare it. How hard is it though? Can I just do it right here? It's a little hacky. Oof, oof, oof. Yeah, okay. Oh, wrong. Let's see, pad. Do we really not define the allowed shapes? I think they're round rect. I don't know what else. It's the only one I remember. Circle might be valid. Rect also sounds pretty good. Unfortunately, I only used round rects in the sample we have, so I'm just gonna keep it 100. Pad.center. Why does it want number? Oy. Yeah, so one of the cases where the naming it's got some legacy naming here. Okay. I think what I'm going to do, does number have to be defined for pad? They really want me to define a number. So sometimes the port hints will have a number. So let's say find pH dot, or pH dot match a number. Then we'll use that. Center does not exist. Say if pad dot shape is equal to rect. We really need to support round rect. People love round rects. Can't change that about people. Why is it saying it's got no center? What is on the pad? Oof. Oh, it's just XY. Okay. No center. And then this is just width. Nice. I'll take it. Okay. You know, this part of the KiCad format is actually pretty good, I think. I almost wish CircuitJSON was closer to this. Right. So now we need to import our file again, forgetting what's going on. Error loading board expecting through hole, SMD, connect, or NP, which is non-plated, or just a hole. We call it in CircuitJSON, we just call it a hole. Yeah, okay. Yeah, actually, funny thing about that, if you have plated hole, you could do plated hole and hole as your pair, or you could do plated hole or non-plated hole as your pair. It's kind of an interesting naming issue, because there's this idea where you don't ever want to have something that's not absolutely unambiguous, or is not relatively, is not relatively ambiguous, meaning in any, without knowing the names of the other enums, it should be disambiguated. I wonder if it's going to help me out. What did it say? What was this error? Too busy ranting about naming. Through hole SMD. SMD. Surface mount. Surface mount. Oh, surface mount device versus surface mount technology. Okay. Function lacks return statement. Oh. Oh, interesting. Just return null. Then we'll say this can return pattern null. Okay. In case we switch the name. Sorry, the window flipping is not working optimally. Test artifact. Okay, we can do a rescue now. Items found on undefined layers top. Okay. Some pasted items are on layers that weren't present. And it looks like, yeah, okay. So I think there's something wrong with the layer conversion. Yeah, we're only defining 2 layers here. So we really need to define, what I would do, what I'm going to do, is literally define all the layers. I'm going to steal it from the test that does this. Are these getting committed? These diff PNGs? I think I accidentally committed a diff PNG probably. That's just going to bug me. Yeah, I did. I accidentally committed a diff PNG. Just messy. Just rude. So we're going to copy out all the layers. To do that, we're going to log all the layers from our other test when it converts them in this parsing test. So we parse it into JSON. We're just going to do KiCad PCB.layers, log it there, button test this file. Now we have this big list. I knew it was a really big list. That's why I was like, oh, I'm not going to write all these down, even if autocomplete kind of gets them. Okay, copy those out. Nice. And then this description undefined thing is kind of annoying and unnecessary. Oh no. Oh no, I messed up the auto format. I feel like I broke something. Hold on. Oh boy. Oh no, what did I do? Okay, I need to go back a little bit. All right. Did I paste like a bunch of nonsense? This is fine. Wait, everything looks fine. Comma. There we go. Okay. And now we remove all the descriptions. Okay. I will be slightly more careful. Remove those commas. Okay, there's probably a couple more. I chickened out. 1, 2. Okay. Cool. We defined all the layers, so you can't complain about that. I do think I feel like we did, yeah, pad.layer somewhere in there. Yeah, that's not right. I'm gonna be how lazy can I be? Function map to KiCad layer. cj.layerref. Yeah, who cares? We should get better on that type, but yeah, basically. Okay, all those are wrong. That's fine. Oh, it wants me to define all of them, but that's not the right user 1 ffab user 1. I don't know. I would have to actually make a board. Partial. Yeah, stringer undefined. Okay. Map to KiCad layer. We'll filter Boolean. It's not the most elegant thing. Filter Boolean doesn't work super well. Unfortunate. Will that do it? Yeah. Okay. There's somewhere else that's using it, the segments, when the segments are created, but for some reason they're being created on the right layer. So I don't know. I don't know what's going on with the segments. They're working properly. But do they run the conversion? Yeah, it runs a little conversion right there. All right. Only works for 2-layer boards, but whatever. It's fine for now. Why did I run that? We do not care about this test anymore. Let's remove the log line. Run our other test. We're in the thick of it. KiCad is going so well when AI was doing all the work. Let's see if we can import it now. Ooh. Hey. So this is super weird. Positions are all wrong. So we've got 2 footprints. Everything is wrong. I'm just trying to figure out what's going on. All right. Could be units. Why do we have a duplicate? Oh, this is our generated file. I was like, this looks really good. Okay, pad 1, pad 2, and then we have pad 1 and pad 2 again. So we do have a duplicate. So we do have duplicate pads, but the question is why? And if they are in the S expression, can we find them in this KiCad JSON? And maybe we can even start adding a couple little tests. So expect layers dot length to be greater than, let's say 2. It's like 20 right now, but top and bottom. And silk screen, I guess. And then we expect the footprint's length to be 2. I believe those are both, yeah, that's passing. What I like about this kind of testing too is it's really easy to like pull out something that you want. So we really want to log that line there. Now we want to make sure there's only 2 pads defined. There should only be 2 pads defined. But we're getting a bunch of pads. What if I log this pad? What's going on here? Whoops. Oh, I see the issue. We're converting every pad in the entire design on each footprint, which is why we get so many. So for, yeah, if type PCB, yeah. No. If elm.pcb component ID is equal to component.pcb component ID. Okay. And now we can add a check, which will prevent a regression. Even though this regression is so unlikely, like, might as well just verify that we fixed it for ourselves. Dot pads length to be 2. Okay. And now let's try importing that to KiCad again. I'm going to delete everything. It's not going to delete our layers, so it's not a perfect delete, but I think it's fine. Nice. Okay. A little bit better. The positions are wrong, right? I'm looking for any kind of ratio that looks off. This is what it's supposed to be. This is what we got. And it's flipped upside down. So we got to keep that in mind. I can't figure it out. Why would those be? It looks like they're roughly double the distance. But I don't know why they would be. What else is suspicious is there's this little purple dot. I think what might be going on is it has to do with KiCad's origins and how tscircuit uses centers of components, but KiCad might use I don't know, top left corner. So we have this thing in our component where we set it to the component center x, but what we might need to do is set it to component minus width divided by 2, something like that, to make it the top left corner. Because that is very common for the origin to be top left corner. Let's regenerate, delete everything, append. Okay, so this one looks better, but not much better, not notably better. Man, this purple thing is really interesting to me. Okay, I think I did. Okay. So let's say that KiCad also does centers. But when we convert the SMT pad to pad, we also have to do it in relation to the component. Okay. So pad.x, pad.y. Yeah, exactly. Cursor just got it. So it's in relation to the component, that x and y position. That makes a lot of sense if that's it. No! Okay. I see this little purple cross right there. It's tiny, this purple cross. It's like 1 pixel, so it's probably not visible. But that little purple cross, I feel like, is the origin that it's setting it to. Because that looks about right for the origin. It's right here. And that looks about right for the origin. And then the origin would be like right here. But I don't see the sky with its yeah, let's select the footprint. Can I? Yeah, I see this. Yeah, the purple dot is like way over here. It's over here now. Purple dot. Okay, let's run some experiments. We're going to set this to 0, 0. We're going to see what happens. It's kind of just taking out the variable that is the pad position. Okay. What's weird is this side looks about right, the right side. That's where I would imagine the center is, but this side doesn't look right. That's not where I would imagine the center is. If we go to the browser, the center is, oh, maybe it is. Oh, you know what? I'm wrong. That is where the center is. And then the pads go to the left and right of it. I'm wrong. Oh my goodness. The AI threw me off. It was the AI. Component.center.x. It's relative to the center, not the width and height is totally irrelevant. Oh my goodness. That should do it. Okay, let's delete that. Append. Okay, that looks about right. These are, rounded, and they're not rounded in the browser because tscircuit doesn't support rounded yet, although I think we need to add rounded support. And it'd be a really good idea. That's a really great contribution, rounded rect support. Unlike KiCad's rounded rect, we would want to supply a radius. Maybe it supports supplying a radius. I don't know. But we would want to definitely supply a quarter radius. They probably allow supplying a radius. That'd be crazy if they didn't. Thank you, Rashab. Good to see you. Good to see you. Yes, we got there. Yeah, believe it or not, I've only been working on this for 3 hours. So we're loading. We're both able to parse and convert to circuit JSON and also convert circuit JSON to KiCad I was able to do it in 3 hours, mostly thanks to the O1 preview from ChatGPT. It wrote the initial parser and it got it really, really correct. So that helped me move really, really quick to get the rest done. It's not so good at circuit.json. I think we need to get a lot more documentation on circuit.json and in a really good format for AI, because it really struggled on circuit.json. But this is looking pretty good. I'm pretty happy with it. There are a ton of issues. If you were watching this stream for a little while, or you're watching it afterward, you probably heard me talk about a lot of things I wanted to do, round recs, just stuff like getting other shapes like plated holes, stuff like that. Please create an issue if you see it. Otherwise, I will create issues for Hacktoberfest and stuff like that and try to divvy it out. And then the next dev stream, hopefully tomorrow, I will work on integrating into the tscircuit dev tool so that you can just export to KiCad. And that'll be nice because what we can do is go up to here, tools. Let's see if this works. This would be pretty cool actually to test. But we should be able to run a design rule check. So make sure that we're passing all the checks that KiCad has built in. I haven't done this in a little while though. Design rule check. I don't know where it is. So I guess I won't be doing it right now, but in the future, we'll do design rule check, measure tool, design rule checker. There it is. I found it. It was in inspect, design rule check. Okay. Looks like this. So you run DRC and it gives you all these errors. So what we're going to do is convert and it even gives you a little arrow to these. So we have a repo called tscircuit checks, and wherever there is a KiCad error, we'll want to create our own check for it inside of circuit.json so that we can give the exact same errors inside the tscircuit IDE. So that's a whole nother class of issues right there. And then circuit to SVG also needs support for drawing these kind of arrows to tell you there's an error. Although this one you would want to enable with a flag. There's already an issue for that. So yeah, but just take a look at these errors if you can read them, because I know this is probably really small. But board has malformed outline. So there's no outline on this board. So that's a great error. Clearance violation, net class default, clearance 7.87 mils. Okay, so this one has to do, I believe, with this pad touching this trace, which we know is okay, but we didn't tell KiCad that because we didn't put in the net information. So we have to put in net information for it to know that. That might be pretty easy. I haven't looked into that, but we have a new tool called circuit.json to connectivity map. It's a repo, and it just generates a net map, which basically tells you what network each pad or trace is a part of. Yeah, and the rest are clearance violations. So this is pretty cool. We should keep working on this. Maybe I'll work on this a little bit tomorrow as we get that export button together. And it'll just be really great for maybe minor tweaks to PCBs when we're trying to order a bunch. It'll also be great to let people import their KiCad stuff into tscircuit so they can use it. But for now, that is it for this stream. I will upload this to dev streams. Thanks for listening. Rashab, good to see you. But I'm going to bed.